Hi, it's Dr. J here. In this video, we will use the relative velocity equations which account for relativistic speeds. I will show you how to set up a problem to use these equations. The question I'm going to use is from the 2020 WACE exam. So a quick recap from my last video where I showed you how to use the equations from our formula and data sheet. So you can see we've got these quite complicated looking equations with our variables u, v and u dash. They are relatively easy to use once you've got your variables set up. So the way that I did it for the best consistency is to write down u, v in alphabetical order and then u dash, where u is object 1 with respect to observer, v is object 2 with respect to observer, and then finally I've got u dash is object 1 with respect to object 2. You need to write it down in that order to make sure that you get all the signs correct when using your equations. So here is the question. So this was question 20 from the question 15 from the 2020 paper. Two spaceships captained by Aditya and Harper are travelling towards each other. They are observed by a person on the Earth to be travelling at the velocity shown in the diagram. Take all velocities to the left as positive. You can see you've got a nice diagram here with all the information that's been given to you. Calculate the velocity of Harper as measured by Aditya. So let's firstly write down our variables. So I have u, v and u dash. So I've got object 1 with respect to observer. I have object 2 with respect to observer, and then object 1 with respect to object 2. Okay, now let's look at our diagram and see what we should assign object 1 to and the observer. We are looking to find the velocity of Harper as measured by Aditya. So we're really looking at probably the best scenario as this being the observer. So the Earth is the observer. We're looking for Harper with respect to Aditya. So this should be object 1. And this should be object 2. Okay, so then let's pop in our values. So object 1 with respect to the observer is 0.75 c left. Object 2 with respect to the observer is 0.5 c right. So we need to make these all the same direction. So it's got to be negative 0.5 c left, and this is what we're looking for. Okay, let's have a look at our equation for u dash. So it's u take v over 1 take u times v over c squared. Let's pop in our numbers. So see how easy it is to fill in my numbers when I've got everything set out already. So I've got this negative 0.5 c over c squared. The c squared terms will cancel out. What I end up with is 1.25 c on the top line. Then I have 1 plus 0.75 times 0.5. And I then end up with 0.909 c. So let's write that out as 9.09 by 10 to the minus 1 c, and that is left. So that's part A for you. Let's look at part B. Harper fires a missile with a velocity of 0.6 c with respect to her in the direction of Aditya. Calculate the velocity of the missile as measured by an observer on the Earth. All right, so let's set up a nice diagram here so that we can set up our variables. So let's write down, Earth. We've got Harper. And we know Harper with respect to the Earth is 0.75 C. And they've got some sort of missile that's coming off. And that missile is 0.6 C. And that's measured with respect to Harper. Okay, so we want to measure the velocity of the missile with respect to the observer on the Earth. All right, so let's set up our U, V, and U dash, and then we can decide what variables are going to go with which object. So this U is going to be object 1 with respect to observer. V is object 2 with respect to observer. And U dash is object 1 with respect to object 2. Okay, so you know the missile with respect to Harper. So they should probably be your object 1 and your object 2. And then you've got your velocity of Harper with respect to the Earth, and you're looking for the missile with respect to the Earth. So you would pick that your missile would be object 1, and that Harper would be object 2. Oh, let's just write a 2 there, and this would be your observer. Okay, because remember, you need to have the equation. So the thing that you're looking for, you need to be using that equation because you can't rearrange them very easily. So object 1 with respect to the observer is what we're looking for. V is going to be object 2 with respect to the observer, so that's 0.75 C left. And then object 1 with respect to object 2 would be 0.6 C left. So we're going to use the U equation. So I've got V plus U dash over 1 plus V times U dash over C squared. Now let's pop those numbers in. I have V, which is 0.75 C, plus U dash 0.6 C over 1 plus V, which is 0.75 C, times 0.6 C divided by C squared. And that actually, if I pop that through my calculator, so those C values cancel out, so I end up with 9.31 by 10 to the minus 1 C left. So now you know the value of or velocity of the missile as measured by the observer on the Earth. Let's move to part C. Calculate the velocity of the missile as measured by a data. So this time we have a data here. We have our missile and we have the Earth. Okay, so now we know the missile with respect to the Earth is 0.931 C. That's with respect to the Earth. And then we have a data, which is 0.5 C to the right with respect to the Earth. And we want to find the missile with respect to a data. So this to me, let's write our U, V, and U dash, and then we can assign our variables, but I think it's popped out to me what it should be. So U is object 1 with respect to the observer. V is object 2 with respect to the observer. And U dash is object 1 with respect to object 2. Okay, so I think that the Earth should be the observer because we know object 1 the missile with respect to the Earth, and then we know a data with respect to the Earth. And then if we make the missile object 1, and then we make a data object 2, then we can find U dash. All right, so U, we know, is 0.931 C left. Now V is going to be 0.5 C right. So we need to make that negative 0.5 C left. And then we are looking for object 1 with respect to object 2. So we're looking for U dash, which is equal to U take V over 1 take U times V over C squared. And let's pop those numbers in. So 0.931 C, take away negative 0.5 C, and then I've got 1 take 0.931 C, negative 0.5 C over C squared. Okay, a little bit of careful calculator work. We've got 1.431 C over 1 plus 0.931 times 0.5. And I end up with 9.76 by 10 to the minus 1 C. Note, of course, that if you end up with a number that is greater than 1C, that you've made an error with one of your signs, most likely. Thank you for listening to this video. In this video, I showed you how to set up a problem to use the relative velocity equations. Be consistent with the way you set up the problems to avoid confusion. Thanks very much for watching, and please subscribe to Dr. J for the latest physics tutorial.